Hello, and welcome to the next lesson in the series on creating a marine structure with Revit 2016. If you'll recall, in a prior lesson, we built an AutoCAD file that had bathymetry, contours, and a pure outline. We also set up our Revit project, enabling us to be prepared to bring in this AutoCAD data. If you haven't completed those lessons, that's okay. You can start off in Revit using the file that we previously built, or open the file called 01site.revit. The AutoCAD file that we'll be using is called 03 contours plus map image plus deck outline simple bathy. This file has the contour lines, the deck outline, and the bathymetry all within this same file. The only thing that will not come through to Revit, unfortunately, is the aerial image. However, the data that we want to work with in Revit, such as the contours, bathy, and pure outline, that will come through. So, going back to Revit, if we go to our Insert tab and choose to link CAD, go ahead and browse to the class file this 03 contours plus map image. Do a single click on it. It's important to do that because we always want to review the settings below before linking in a CAD file. The first thing we want to make sure is that current view is unchecked. The next thing we'll do is ensure that colors are preserved. Layers and levels, we'll set this to visible. That way any frozen layers in AutoCAD will not be linked in. And this one, for the first few times that I worked on a project involving civil units and Revit, it really tripped me up. But I've learned to defeat the auto-detect units. Leaving this as auto-detect will not work. You must override it. If your AutoCAD file is in decimal feet, like ours is, you have to set the import units to feet. The next thing that you'll want to do is uncheck correct lines that are slightly off axis. Because this is a site file with contours at specific orientations, we want to ensure that Revit does not defeat these lines. The other thing that we'll do is we'll change our positioning and make it auto center to center. Now you might right there be thinking, wait, isn't that going to defeat the purpose of doing it in AutoCAD to begin with, to get our data in a geographically correct location? And initially you might be considered correct. However, what you really want to focus on is we're bringing this data as a reference into AutoCAD or into Revit. And this reference data, we're also going to extract the coordinate system from AutoCAD and tie it into our Revit project. Using the center to center allows us to locate the AutoCAD data near the center of our Revit model's origin. We'll go ahead and place this AutoCAD at MLLW, which is a Revit level, and that is tied to Revit's 0 elevation. And it will tie to the AutoCAD's 0 elevation, which will ensure that our bathymetry and contour lines come in at the correct elevations. Orient to view, you can leave that checked or unchecked. It doesn't really affect us in this type of a view where we're importing a CAD file. Go ahead and click open, and then double click the wheel on your mouse to be able to see your data. Now in AutoCAD we had a bench mark near the tunnel that went underneath the railroad tracks. And here in Revit we want to try and get that to be the same position that the project base point occupies. So what we'll do is we'll take our linked CAD file, we'll select it, and then use the Move tool. We'll zoom into where that lobe is, type SE on the keyboard, letter S as in Sam, E as in elephant, and pick the end point of that line, which is where we should have tied our AutoCAD point in. And then we'll zoom back out and zoom back in to where we have our point for our site and survey and project base point. Now, when you hover over that, you should get a point object snap. You can confirm that by looking in the very bottom left corner of Revit. It should say point of site survey or point of project base point. Go ahead and left click on that to move the referenced CAD file to that position. You can go ahead and deselect it at this point. So what we've done is we've essentially built a project base point. Normally this would be tied to a real-world project benchmark at this location. But because we're dealing with a arbitrary location, we're just using this for right now. The next step that we want to do is we want to bring in the AutoCAD coordinate system and use that within our Revit project. To do that, we'll go to our Manage tab. And on the Manage tab, you'll find a number of different panels. Going from left to right, if you have out-of-the-box settings, you'll have Select, Settings, and then Project Location. Now, a lot of my buttons are scrunched up because of the resolution that I'm working at. Normally, I work at a larger resolution, and these boxes will expand to take up the higher resolution. The button that we're looking for, though, should have the same icon regardless of your interface. It'll have the three colored arrows representing your X, Y, and Z axes. And when you click on that, it'll give you a flyout that has 4 options. And this gets into something that strikes fear in the heart of many people that are new to Revit. And what this is going to allow us to do is acquire coordinates from the DWG, just as the name would imply. The great thing about this tool is all we have to do is have Revit select the linked DWG. We're not concerned with where we select the linked DWG. We just simply need to select it, and Revit will interpret the coordinate system of the AutoCAD file. You'll notice that once you move your mouse into the drawing viewport, Revit in the bottom left corner asks you to select a linked project from which to acquire shared coordinate system. So we'll go ahead and left click on that DWG, and that's it, we're done. Shared coordinates in 2 minutes or less. So really that's the simple process of bringing in a DWG and enabling shared coordinates. Now one thing that happened, I'll point this out, when we did that, if you zoom in, you'll notice that we only have one icon left here, which is our project base point. It's now reading coordinates close to what they should be in the real world. If I double click the wheel on my mouse, all of a sudden everything seems to disappear except my icon for my project base point and my survey point. It's at this point that you will want to do something special with the survey point. This is a step you'll only want to take after setting up shared coordinates. What we're going to do is we're going to unclip the survey point. Then we're going to use the Move tool to move that survey point back to our project base point location. And if we zoom in close enough, we'll ensure that we get this survey point tied directly back on top of the project base point. And you can see from the tooltip as well as the bottom left corner that I've selected an object snap that's going to place my survey point on top of my project base point. I'll left click to place that and then reclip it. Very important to do. The other thing that I want to do, as long as I have my survey point selected, I want to hit the little thumbtack or pin. I want to pin that in place so that it cannot move unless by deliberately doing so. So that will lock our site point into position, enabling us to have a Revit model that is geo-referenced along with the CAD file. This is really important down the road when we get into collaboration with other parties where they are using different software. Perhaps we're doing clash detection in Navisworks. Perhaps we're exporting our AutoCAD files to our Revit project to AutoCAD files to another consultant. These are all scenarios where having shared coordinates set up properly is very important. The last thing that we want to do is we want to build a topo surface from the AutoCAD file that we've linked in. To do that, go to your Massing and Site tab and click the topo surface command. The next thing we'll do is choose to create from an import instance. Now, this usually has a lot of beginners scratching their head because they go, import instance? I thought we linked the CAD file in. True, but in this case it doesn't matter. We'll still select that option. We'll pick the AutoCAD file. We'll click Check None on the layer box and make sure that we only bring in major contours. We'll click OK, and Revit will think about it for a minute. It's going to use all those contour lines and bathy lines to build us a land object. And there it is. You click the green check mark to finish, and you now have a Revit topo surface here within the model. You can check it out in the 3D view that we configured earlier. There it is. We now have a topo surface that reflects both above and below water land surface. So hopefully these 3 steps, linking the CAD file, positioning and acquiring coordinates for shared coordinate positioning, and building a topo surface, help you see how easy it is to get going on your site conceptual plans. Thanks for watching, and I'll catch you next time.